Although the SRv6 industry has been developing rapidly, concerns remain about the transmission overhead brought by the large SRv6 header. To improve SRv6 transmission efficiency, multiple SRv6 compression solutions emerged in the industry around 2019. Among these, SRv6 and C-SID both aim to remove redundant information from segment lists. As such, the related IETF working group integrated the two solutions into the C-SID solution. The C-SID solution defines three flavors: replace C-SID, next C-SID, and next and replace C-SID. The three flavors differ in C-SID orchestration and update modes. The core idea of the replace C-SID flavor is to overwrite different information. This flavor uses the SI field to indicate the position of the active C-SID and copies the active C-SID to the IPv6 field, which is short for the IPv6 destination address field. The core idea of the next C-SID flavor is to shift bits to remove the used C-SIDs from the stack in a fixed sequence, thereby updating the IPv6 As a combination of the preceding two flavors, the next and replace C-SID flavor first implements the actions defined by the next C-SID flavor and then those defined by the replace C-SID flavor. The C-SID solution adds two key concepts. One is the C-SID concept. The parts that differ between 128-bit SIDs are called C-SIDs. The other is the C-SID container concept. To be compatible with common SRv6, 128-bit SIDs in a segment list are regarded as C-SID containers. A C-SID container is also 128 bits long and adopts the SL update mechanism. The C-SID container, indicated by the SL field, is the active one. Now, let's look at the encoding formats and data forwarding processes of the three flavors in 32-bit C-SID scenarios. For the replace C-SID flavor, the first C-SID container carries only one C-SID, meaning that a 32-bit space may be wasted. For the next C-SID flavor, each C-SID container needs to carry a locator block, leading to information redundancy. By contrast, the next and replace C-SID flavor adopts the next C-SID flavor encoding format for the first C-SID container and the replace C-SID flavor encoding format for subsequent C-SID containers. This avoids the disadvantages of the preceding two flavors, achieving the optimal compression efficiency. In this topology, 32-bit end X C-SIDs with the replace C-SID flavor are allocated hop by hop. During forwarding, the SL field points to the active C-SID container, and the newly added SI field points to the active C-SID in the active C-SID container. SRv6 nodes replace the C-SID in the IPv6 DA with the active C-SID to update the IPv6 DA. In this topology, 32-bit end X C-SIDs with the next C-SID flavor are allocated hop by hop. During forwarding, the SL field points to the active C-SID container, which needs to be copied to the IPv6 DA field. The C-SID container contains multiple C-SIDs, and the leftmost C-SID is the active one. SRv6 nodes perform table lookups and forward the packet based on the locator block and active C-SID in the IPv6 DA. Each time the packet passes through a hop, the active C-SID is shifted leftward so that it is removed from the stack, making the next C-SID become the new active C-SID. In this way, the IPv6 DA is updated. In this topology, 32-bit end X C-SIDs with the next and replace C-SID flavor are allocated hop by hop. The overall forwarding process is divided into two phases. In phase 1, the packet is forwarded from N1 to N2 based on the next C-SID flavor. In phase 2, the packet is forwarded from N2 to N9 based on the replace C-SID flavor. Here, we compare the segment list lengths of common SRv6 and the 3 C-SID flavors when a maximum of 30 hops are supported. The comparison result indicates that the next and replace C-SID flavor is the most advantageous in 32-bit C-SID scenarios. The next C-SID flavor outperforms the replace C-SID flavor when there are 2 or less hops, but increasingly performs worse than the replace C-SID flavor when there are 5 or more hops. In April 2024, the European Advanced Networking Test Center released a report announcing the completion of SRv6 C-SID solution interoperability tests covering multiple types of services such as L2 VPN, L3 VPN, and eVPN.